Okay. Angle of incoming sunlight, believe it or not, is not the only thing we care about. An interesting fact is, if you live on the equator, the sun is almost directly overhead year-round. And the path that the sun takes across the sky is very similar in shape year-round. As a result, areas near the equator, areas on the equator, get virtually no change in day length. 12-hour days year-round. However, the further away you go from the equator, the greater the change in day length from winter to summer becomes. And this map actually identifies that. And the reason why this happens is because the Earth is tilted. This actually causes one of the two poles, either the North Pole during March through September, or the South Pole from September through March, to be pointing almost directly at the sun. Meaning the sun is always out during that particular time at the pole. And so the further away you get from the equator, the greater the change in day length is. So if you're at 30 degrees north, this is in the mid-latitudes, you get roughly around 14-hour days in the summer, 10-hour days in the winter. 50 north, you get 16-ish hour days in the summer and 8-hour days in the winter time. And I'm sure that you've noticed this if you've ever traveled somewhere further north, like Seattle or Alaska or Canada or England or much of Europe. They're further north, they get longer days in the summertime, but they get shorter days in the wintertime. Now, why this is important is because even though higher latitude locations actually get less intense sunlight, during the summertime, the sun is out much longer. And that actually brings us to a pretty interesting consequence. When taking into account the angle of incoming sunlight and the length of the day, which are both very important, we actually get a pretty interesting consequence. And here's what the consequence is. If you live near the equator, there's very little variation in the angle of incoming sunlight. Very little variation. However, and as a result, and there's no variation in the length of the day, as a result, there's very little variation. If you actually take a look at this graph, very little variation in the amount of incoming solar radiation. On the other hand, the further away you go from the equator, the difference between winter and summer becomes greater and greater and greater. And in fact, believe it or not, in the summer months, the North Pole actually receives more insolation, more incoming sunlight than the equator does. Think about that. The pole receives more sunlight than the equator does. But Terrence, why isn't the pole warmer? Well, I'm glad you asked. The reason why the pole's not warmer is because even though it receives more than the equator during the summertime, it receives practically none during the wintertime. And as a result, it still has a major accumulation deficit. Overall, it doesn't receive as much radiation year-round as the equator does. Hence, it's colder. But this does bring one more interesting consequence, and you're going to dig into this a little bit in this lab. I have two images here, and these both represent average temperature maps for January and July. And there's a few things I want you to notice here. First, look at the equator. Compare the temperature at the equator in January to July. How much of a difference is there? spoiler alert, there's virtually none. Oh, and Fat Thor. Oh, sorry, that was an Avenger spoiler. Hey, it's been a few months. So, yeah, there's virtually no variation. On the other hand, look at the poles. In January, the North Pole has temperatures of -35 and even as low as -40. Whereas, in the summertime, +40. Much greater variation. And this, of course, is caused by the variation in insolation, variation in incoming solar radiation. There's not much variation near the equator, major variation near the poles. As a result, very little temperature variation near the equator, major temperature variation near the poles. One last interesting fact that I'll bring, and this actually has major implications to our lives. Have you ever noticed that it's typically stormier in winter? Living here in California, we get all of our rain in the wintertime. Well, here's why. If you actually take a look, compare the temperature at the equator, actually let's do this one right here, to the temperature of the North Pole. The difference is stark. We have temperatures of 70, 80 degrees at the equator. Meanwhile, we have temperatures of -30 and -40 at the poles. That's a major temperature difference. That's a temperature difference of 120 degrees Fahrenheit. On the other hand, let's look at the summertime. Same difference now, we're going to compare the same two places. The equator, we have temperatures in the 70s and 80s. The pole, we have temperatures in the +40s. Instead of a 120 degree difference, we only have a 40 to 50 degree difference. Well, this brings us to an interesting fact. The greater the temperature difference, the stormier the weather. And we'll actually uncover that when we talk about the jet stream. But for right now, the greater the temperature difference, the stormier the weather. Big temperature difference for the Northern Hemisphere in January. Stormy weather. Small temperature difference in July. Stormy or less stormy weather. Well, what I want you to get here is that the hemisphere that's experiencing winter has a much bigger difference between the equator and the pole. The hemisphere experiencing summer has a much smaller difference between the equator and the pole. And you can see this in the southern hemisphere as well. Between the equator and the pole in January, that's their summer. Not a major difference, a difference of about 60 degrees Fahrenheit. On the other hand, between the equator and the pole in July, that's their winter, we have a temperature difference of over 120 degrees Fahrenheit. So again, bigger temperature difference, stormier weather. All right, that's it for this investigation. That's all that you need to know for this investigation. So if you have any questions, please don't hesitate to reach out to me.